In this video, I lay out a calculus-based way to get from a production function to the cost function, and that is an expenditure minimization. Along the way, I'll introduce you to a method of doing a constrained optimization problem using calculus, and that is the method of Lagrange. So let's just go ahead and start in with a very common production function. Now remember from the last video, production functions are generally functions of capital and labor that tell us for a given bundle of capital and labor how much quantity can we produce. Here is a specific type of production function. This is called a Cobb-Douglas production function. Now, you may recall that what we're looking for is, given a target quantity, how do we achieve that quantity? How do we produce that quantity by picking capital and labor so as to minimize the cost of producing that quantity? And as I argued in the last video, that will look like the tangency between an isoquant and an isocost. So let's write out an expression for expenditures. It's just price of capital times capital. That's how much you spend on capital. Price of labor times labor. That is your total expenditures. This is what we're going to try to minimize. And this firm can control how much capital and how much labor they actually use. They take price of capital, price of labor is given. And they're going to minimize this subject to producing Q equal to K to the alpha, L to the 1 minus alpha. And so there is our minimization problem, and that is the problem that we hope to solve. If you want to solve a maximization problem or a minimization problem, and it's well posed and everything, what you can do is you construct something called a Lagrangian. That term in the parentheses equals 0. So if I add 0, no harm, no foul. So I'm going to take the first order condition with respect to capital. I can do a similar thing for first order condition with respect to labor. What I did there is I just took the derivative of this script L Lagrangian with respect to capital for this line. I set it equal to 0. Did the same with respect to labor for this line, and I set that equal to 0. This will give us some critical points. In fact, we're not done. We also take it with respect to the new Lagrange multiplier, this lambda character here. So there are 3 equations and 3 unknowns. When we solve for that, that will give us the cost minimizing input bundle. That will give us the location of this tangency between an isocost and an isoquant. I'm going to make some room by erasing some of this. Now first things first, I'm going to take all the negative stuff and bring it over, and so I'm going to rewrite this system of equations. So there we have our 3 equations and 3 unknowns, just rewritten a little bit. Now what we're really interested in is the values of K and L that are the solutions. We're not really, at least at this point, interested in what lambda is. You may be interested in what lambda is at another time and place, but right now we're not particularly interested. So one way to get rid of lambda is to just take the ratios of these first 2 equations. The lambdas will cancel, and we'll get something that's a lot simpler to work with. So let's go ahead and do that. We get pk over pl on the left-hand side. The lambdas will cancel. We'll get an alpha over 1 minus alpha. Then what we'll have is we'll have an LK to the 1 minus alpha. That's going to be divided by a K over L to the alpha. That's just going to be equal to alpha 1 minus alpha times L over K. Now this is a pretty simple relationship here between L and K. I have another relationship between L and K that is given by the production function. I'm going to take this equation that's in this box and I'm going to rewrite it as L as a function of K. That's this equation rewritten. And then the other equation we have is Q0 equals K to the alpha L to the 1 minus alpha. What we can do is we can take this and plug that back in. This will get Q0 equals K to the alpha. And then we'll substitute this expression for L, which is a function of just capital and the other parameters here. You notice that this K has exponents that sum to 1. So we set that, just factor that out there. Now this may look a little bit complicated, but once we take that and rewrite it, we can express it as K equals 1. So basically multiplying or dividing both sides by this over there. And if you want a more convenient expression for our optimal capital, and what we have is our expression for what this number is here. Generally, in terms of the target quantity, the Cobb-Douglas production parameter, share parameter, prices of inputs, and again, the Cobb-Douglas share parameter. We can do the same thing for labor. I won't belabor that point. What we'll get is we'll get something that looks awfully similar. It'll be to the alpha. Everything else will be in the same sort of positions. And that will be our expression for our labor demand curves. These are demand curves. These really are input demand curves. But they are also equations for our optimal bundles there. Now, I motivated all of this by asking how do we find the expenditure function? How do we go from our production function to the expenditure function? Well, all we have to do is ask how much does this bundle, K star, L star, cost? Well, that is going to be our expenditure function, our cost function. It will be a function of price of capital, price of labor, and it's going to be PL times L star, that mess there, plus PK times K star. So there you have it. There's a cost function. And this may have been a bit calculus intensive, but now you see what kind of math we do in economics. And it's not just doing graphs and hand waving, but we can start with a production function. We can get numbers for each and every one of these things. We can ask what's the target quantity. We can ask, well, what is the share of expenditures on capital and on labor. We can get that stuff in the data. We can also get the price of capital, well, that's a little bit tough, and we can get the wage rate. We can put those into this model, and we can figure out really well, we can pin it down very closely to this cost function. And as I mentioned in that previous video, this cost function is going to be related very intricately to supply decisions by the firm.